You're listening to the Valley Current.
Hey, Doug.
There you are.
Hey, you look great, man. How things going?
Good, excellent. Yeah, very busy week, actually.
Yeah, you're staying really busy, and you've allocated a bit of time to talk about your new book. Actually, you have like a whole series of books.
Oh, yeah.
And you're sort of the expert in the area of cyber measurement of cyber threat, which a lot of people for many decades and years thought couldn't really be measured. So why don't you tell us your journey of how you got to be the famous author that you are and famous expert in your field, starting with maybe even when did the thought occur to you that, hey, this is a field I want to get into? Like, did you dream about it in high school? Like, tell us where it all started.
No, it's not something I dreamed about in high school. I don't know if anybody dreamed about, being a quantitative analyst so much. Maybe I dreamed about being a physicist or an astronaut or something, but, not this kind of job. So this was my fourth book, How to Measure Anything in Cybersecurity Risk. My first book was How to Measure Anything. And I did mean it literally. And so really this How to Measure Anything in Cybersecurity Risk book really comes from where that first book started, which was 35 years ago. I was at Coopers and Lybrand in management consulting services, and I was building quantitative models back then, except they were in Fortran and Lotus 123 were our tools primarily. You might remember those.
I remember VisiCalc. We represented.
Yeah, or VisiCalc. Yes, right. I think we had gotten kind of advanced and moved beyond VisiCalc to Lotus 123 by that time in 1988, I suppose. Right. I was doing, Monte Carlo simulations and various sorts of management science, decision science, OR kinds of problems. And every once in a while, I'd run into a client that said that something wasn't measurable and we couldn't quantify it for this model. And, as a brand new MBA, I just believed them. I just thought, they're experienced. They know what they're doing. What do I know? But actually, there were several times I ran into that kind of a comment, and I knew it was measurable. In fact, sometimes we had just measured that sort of thing at a previous client. Right. And so I started to doubt this. I started to doubt their confidence that they could know that they would be familiar with all the measurement methods somehow and know that none of them would ever apply to a specific problem. Someone's mastered all fields of empirical science, statistics, logic, math, all of that, and concluded that none of them can address the specific problem they're dealing with. I just started to wonder if that could even possibly be true. And eventually, I came up with a list of reasons why people perceive things to be immeasurable. And they're always misconceptions. Right. So that's what I talked about in the first book. And like I said, I did mean that literally. I meant you could measure anything. If there's something that's important to you or your organization or your government, if it has any bearing on your life at all, it has observable consequences. And if we make judgments about things, just subjective judgments about things, people are always making subjective judgments about quality of life and art and, customer satisfaction. Those subjective judgments are also based on empirical data. They're historical experience. The only difference is it's selective recall, and it's probably flawed inferences when we do that math in our heads. We're not literally doing math, I don't mean, but we're doing some kind of a judgment. We're taking a collection of sort of anecdotes from our past, and we're merging that with a bunch of other irrelevant things that actually affect our judgment that shouldn't. There's all sorts of noise that works its way into our judgment, and there's all sorts of inconsistency that we have. So I developed this concept that, there's really measurement methods for everything that you're talking about. I haven't heard anything that's truly immeasurable yet. And it's based on people either misunderstanding what measurement means, because in the empirical sciences, it just means a quantitatively expressed reduction in uncertainty based on observation. It's not an exact point. It hasn't meant that for about a century in science. Right. Sometimes they misunderstand the object of measurement. They don't know how to measure innovation or collaboration or reputation damage from a cybersecurity attack or something like this. in those cases, it's because they don't quite know what they mean by those terms.
Right.
They have to figure out what they mean. In fact, those are what I might call an umbrella term that really represents a big set of different things that you have to unpack to even figure out what you're talking about. And then finally, the methods of measurement. How does statistical inference work? There's been a lot of research on this, but people have some profound misconceptions about random samples. Even after taking college stats, they leave with some misconceptions. In fact, it turns out, this is relatively recent research, but it turns out that people figure out how to integrate misconceptions they already had into what they're learning in certain courses like statistics and psychology. So just learning those chapters don't necessarily overcome your misconceptions. In fact, people figure out how to integrate their baggage. And then they still end up saying things like, that's not a statistically significant sample size. No statistician will tell you there's any such thing as that, by the way. There's something called statistical significance. Right. And obviously there's a sample size, but there's no universal number where if you're one short of that, you can't make an inference. The math doesn't work like that at all. So people have all these misconceptions.
So let's just use an example. Everyone was commenting about this unbelievable settlement outcome that occurred in this case that existed between this voting company, Dominion, and Fox News, where they were claiming like 1.6 billion of damages, pretty big number, pretty round number. I never heard how they got there because the value of the company based on its last investor was something like 80 million. So it was like 20 times the value of the company. So I'm using kind of a yardstick that says, how the heck can you get 20 times the value of the company when, number one, even if there's punitive damages, there's a constitutional limit that's supposed to be no greater than 10 times the amount of compensatory damages? And can the compensatory damages be more than the entire value of the company? The company still exists, is still manufacturing machines, still selling machines. And they ended up with a settlement that was roughly about half, it was close to 800 million, which is quite a payday for the lawyers that handle it, of course, on a contingent fee basis.
Yeah.
A separate story. But how do you, when you look at that example, what do you say to yourself?
Well, first off, I think it's, a negotiation tactic. I think it's about what you can get.
Right.
I mean, you can make the case they settled. Now, I'm not familiar with the details of what the Constitution says. Apparently, if the Fox lawyers would have made that case in court,
right.
If they really believe that a judge would believe that claim, well, then they should have gone ahead to court. But I think I'm going to go out on a limb and say that the lawyers representing Fox probably are a little bit more familiar with the details than either of us are, and they realized that they were in trouble. So I'll have to look into what you say the constitutional limits are on punitive damages. Right. So apparently, though, the lawyers on both sides didn't think that was a
right. You could say there was other factors being measured than just what the outcome by the trial judge, jury, the rest, and the appellate court. There were other non-judicial factors or non-adjudicative factors, like what does this do to our reputation? What does this do to our credibility? What does this do to our brands going forward, right? These are all... Sure. Right.
Well, they, for all I know, and again, I'm speculating here. I wasn't expecting this particular question, but maybe they were expecting on a trend internationally, because they do actually do this internationally. Right. Maybe they were seeing a trend internationally prior to this, and they had legitimate reasons to forecast they were making more money or could have made more money. But the bottom line is that number is a strategy. That's the way to think about that. That doesn't necessarily have to be an empirical measurement itself, other than what you think you could get as a negotiation strategy. That's what you're really optimizing there. Right. So that's a different question than forecasting how much revenue they lost with this event as opposed to without that event. That's a different question.
So are you brought in sometimes as an expert to help with these difficult to measure tasks? You see that kind of work in your consulting practice?
Oh, yeah. I mean, that's, certainly all of our all of our work with companies that are developing a new product or doing enterprise risk management or operational risk or cybersecurity risk, or trying to forecast the revenue from new pharmaceutical products, or whether or not they should develop this new oil field, or even things like environmental policy and the value of renewable energy technologies and so forth. These are all things we actually do. And I have been an expert witness on civil liability cases. One was a childhood industry, which was pretty gruesome from the hospital. And so how do we monetize something that a young man had to live with his whole life? So that's one item that comes up quite a lot. There's the first edition of
right. I put your first book up because you marked this as you're working at Coopers and Lybrand. I think they ended up merging and they're no longer in existence, but it was a great CPA firm for a long time. And you come up with this idea of you can actually measure anything where it's pretyou general. The statement's pretty general, but I think the focus is more business, right?
Yeah, sure. Well, in fact, you're right. It merged with Price Waterhouse, and now it's Price Waterhouse Coopers, or PwC, is what people know by. And so, this was the first edition. It's in its third edition now. So I like the covers a lot more now in the third edition, and it got thicker every time. So the blue one on the far left there is the third edition there.
This is the latest version, right? We're going to put
yeah, that's the latest one. Yeah, that's right.
And so you're essentially got a franchise, because I don't think anyone else, you tell me if I've just got this wrong, I don't think anyone else has made the bold claim or explained it in the way you have in this book, right? This is kind of your area.
Yeah, I mean, not exactly, sure. I mean, there's certainly a lot of people that I cite lots of other people in the book. I think, if anything, I've collected a lot of things to make a coherent case about this. So I cite a lot of sources about the weird things that affect our judgment and our subjective estimates of things, and how much better off we are with even relatively naive statistical models. Even relatively naive models seem to outperform expert judgment in a huge variety of topics. So I cite a lot of other researchers on that. And I throw in some case examples of things that we've measured that seem really hard to measure. I actually developed, for example, the algorithm the Marine Corps uses for forecasting fuel for the battlefield. It's one of the case examples in the back. I throw in other historical examples where people might think that, hey, there was no way somebody could have measured that. How did Eratosthenes in ancient Greece estimate the circumference of the planet? He didn't circumnavigate the planet. He didn't have satellites. So how did he do it? He made inferences by looking at the length of shadows in different cities at the same time. And you can make a logical inference from that. So I think a lot of times what people run into is they think that they don't have enough data, but they need a lot of data. And this is a completely unique measurement that's never come up. What I tell people is just the opposite. You have more data than you think. You need less data than you think to improve upon your current judgment. And it's probably been measured before. You're probably not unique here. So I'm just assuming that most of us are not going to win Nobel Prizes, because we're not going to measure anything truly unique. I haven't yet. And I measured a lot of weird stuff, and none of it was truly unique. None of it was something that nobody had measured before. I simply applied methods that had been developed in other fields, maybe to a slightly different field.
Do you see the future as AI finding patterns in the data faster than the way you do it? Like, do you imagine a future where artificial intelligence, which has got obviously a lot of news these days, is going to train on this massive amounts of data, or even small amounts of data, and produce some informational value that extracts something that perhaps is the next sort of version of the book? Or what do you see happening going forward?
I did a little experiment on LinkedIn. I put a prompt in ChatGPT. I said, write the outline of a book called How to Measure Anything with AI, as if it were written by Doug Hubbard, the author of How to Measure Anything, right? And it generated a plausible, it's not exactly what I would have written, but it wasn't implausible. If I would have given somebody that outline and said, this is my idea for a book, even my editor, they would have said, oh yeah, that's the outline. Yeah. It would have seemed completely coherent. I think, and my clients have asked me about this recently, because we're, currently involved in some big analytics studies, including like a large investment banking financial service where they have to do analysis of lots of companies to make recommendations about what should be in their investors' portfolios and things like this. And they're asking us, a couple of them had asked us, will AI replace us? Right? Because we're developing these quantitative models. The algorithms, they use algorithms right now. Algorithms haven't replaced them. But will AI, sort of going a little bit further than just the generic algorithm, right?
Right.
And I said, I think, and this is my forecast, I don't know if AI is going to replace those analysts. I think analysts who use AI will replace analysts who don't. That's what's going to happen. We do know a lot of things about adoption rates of new transformational technologies. This has been happening many times in human history. And true, every technology is unique and uniquely disruptive, you could say. But we do see some patterns through all of this. The industrialization of farming did not create a population which is 90% unemployed farmers. Even though that's what most people used to do at one point in time, we're not mostly unemployed farmers. We moved into other kinds of jobs. And I think that's the same thing that's going to happen. I am interested in AI risk because I've heard this term a few times. And I think, like a lot of things, I'm not sure people really know exactly what they mean when they say it. They just have some general ideas about some loosely connected concepts that they haven't quite defined about there's some risk related to AI. Some specifically identifiable anecdotes. But even all the specific anecdotes I hear about are things that we already deal with in other risks. Like people, apparently somebody uploaded a lot of company classified data to an AI to help them analyze that. And that was like a big security breach. And I said, well, but that's no different than just sharing it with somebody outside the organization. Why would you do that? You already have policies against that. You try to secure those sorts of things. I think the compared to what question is something we have to keep asking all the time. If somebody says, well, what if, AI gives us bad information and we act on it? What if a doctor uses AI for a diagnosis and it gives bad information? I go, well, how is that different than just asking another doctor who could have made an error, or another human being? Of course you have to be skeptical. That doesn't mean I won't ask somebody else for an opinion, even though I'm not going to have 100% faith in that person's opinion. We can use our own, higher cognitive abilities to assess these things. So number one, some of those risks aren't any different.
Right.
And, sharing information, doing things like, not trusting what's coming out of it, of course, just like you wouldn't another person necessarily. Is it possible that because somebody is using AI, they have more confidence in that and act with more confidence than somebody else? Well, I guess I could ask that same question with somebody with letters like PhD behind their name or something, right? I mean, yeah, of course, you still want to be, use your higher reasoning skills on those things. I think there's a few other things where there might be a more legitimate risk. Once you parse out the things that are not really different than other kinds of risk we already deal with, they're just a different form of the same thing. There's probably a few other ones. Would AI, for example, be able to generate, let's say, on a massive volume, large numbers of attacks, exploits for a large number of vulnerabilities? Scan, could we do that? I mean, in a way, there already are algorithms for this. For some things, but could AI even make that better? So if you had an adversary, a military adversary that was using something like this, could you do that? Would that make it even more of a threat? Well, that's possible. Actually, that's a possibility. And the only way we can attack that is have our own AIs, just like nuclear bombs. One side's got it, the other side's got to have it. Right. So we have to do that sort of thing. I think there is I asked ChatGPT, what the risk. I had to prompt it to train it to be able to put probabilities on things because it won't do it up naturally. You have to give it a series of prompts about how it could put probabilities on future events, because otherwise it'll say, as an AI, I can't put probabilities on events.
Right.
But I gave it a prompt. I have a whole series of prompts just for doing probabilistic forecasts. And we actually measured its skill at this. It's about as good as the average untrained human. So we've actually calibrated more than 2,000 human beings through our calibration training, where we train people how to provide calibrated probability assessments for various events. It's a skill you can learn. And we benchmark them at the beginning of the training. We see how much they improved during the training. ChatGPT is about as good as the benchmark.
It's not bad.
It's not bad.
Right?
So, and it's pretty good at making adjustments. It's better than humans at actually making the adjustments. So once we tell it that it's overconfident, for example, and here's how to change it, it actually reacts a little faster than humans would to this. So I asked ChatGPT what it thought the likelihood of a scenario like Skynet would be by 2035.
Okay.
Skynet from the Terminator series.
Yeah.
It did a probabilistic analysis. I think there's a 10 or 15% chance that would happen. And I said, well, that's not implausible. It didn't say 80%. It didn't say, 1 in a million either.
Right.
I don't know if that's not too far off from what I think a lot of people might have said, even experts in the field, I suppose. But we could, try it with experts in the field. I should survey a bunch of them and see how well they do. Right?
Yeah. So I was going to ask you as my next question. Did you try to compare what it came out with what human experts might say on that same question? Right?
Yeah. Well, I didn't compare it to human experts on that question, but the way that we tested it originally was the ChatGPT has a training data period that cuts off in September 2021.
Right. So
it doesn't know anything that happened after that in terms of current events. Well, we know lots of things that have happened since then. And so I asked it to forecast things like what the Dow Jones would, a 90% confidence interval for what the Dow Jones would be in January of 2022. Things like how many COVID infections there would be by a certain point in time, et cetera. Let's see, several other trivia questions like that, or which team might win the Super Bowl on, for 2022 or something like this. Right. We knew all of those things, and we would ask these questions. It would put either discrete probabilities or 90% confidence intervals on continuous variables. And it just gave the answers, and we compared it to what we knew actually occurred. And that's how we came up with, well, it's about as good as the typical untrained human.
Interesting. So let's turn to, then you focus on cybersecurity risk in your next big book, which now is in its second edition, right? That's what you're out talking about, called How to Measure Anything in Cybersecurity Risk, which has traditionally been a very difficult area to figure out and a very current area. So how did you come up with this idea for this book? Tell us.
Well, I knew I needed to, even though I'd done some risk analysis in cybersecurity, I needed to pair up with a real cybersecurity guy. A CISO with some clout. So that's why I paired up with Richard Searson. And now he's actually the chief risk officer for Resilience, which is a cybersecurity insurance company. So they got a lot of great data on this kind of stuff, and we try to leverage that as much as possible in the second edition here. So I was just running into the same kinds of issues in cybersecurity as I ran into in other areas. People thought this was unique. Everybody says they're unique. I mean, I've had clients in nuclear power and pharma and aerospace and, environmental policy, Silicon Valley startups in a variety of areas. And they'll all say, yeah, but we're unique. We're not like all those other ones. We're unique. And I go, yeah, you are unique, just like everybody else. Everyone's almost uniformly unique, apparently. And so I heard this from cybersecurity, and I said, well, I think that, the way that we think about risk, the human brain isn't different in cybersecurity than it is in these other areas. They make the same kinds of errors. And remember, all we have to do is have less error. That's the key thing. People imagine that has to do with the concept of measurement I mentioned earlier. It's not an exact point. People think that something's not measurable in cybersecurity because they can't predict the future exactly. That's not what we're talking about. We're talking about less error than there was before. What's your current error? There's plenty of current error,
right.
just with human intuition, expert intuition. That's got a track record that sets a bar that's not too easy, not too hard to beat. Right. That's an easy standard to pass. We make all sorts of errors. We've measured things like how overconfident cybersecurity experts are. They're extremely overconfident. We've measured things like how inconsistent they are in their judgments. We know that if you just ask a cybersecurity expert the same thing at a different time, they would have said a different answer. We've measured that. If you look at all the probability judgments about likelihoods that cybersecurity experts might make judgments about, you look at the variation in their responses, you can measure that about 21% of the variation in their responses is just random inconsistency.
Yeah, you would call that noise, isn't that?
Yeah. It's a noise-related problem. And in fact, Kahneman wrote a book about that. And in fact, he actually cited some sources that I've been using for a long time. I used to be citing these very obscure academic papers from decades ago. And I thought, I wish somebody would write a more current book about this. Then Kahneman comes out with this. Right. You have to look at the bibliography actually to find it. But there it is. Oh, hey, somebody else is talking about these methods. But yeah, that we've been measuring noise in cybersecurity judgment for 20 years now, and a lot of other areas. This is a persistent issue. And it turns out that inconsistency is so high that if I'm just able to statistically smooth out the inconsistency, in other words, add an algorithm on top of expert judgment, the algorithm is better than the original expert judgment. In other words, the algorithm that simply models expert judgments is better than the experts it models. This is remarkable. It sounds like perpetual motion or something, but it's not. All it does is remove inconsistency.
Yeah, I mean, your view is a human being, if it's hungry, will do something different than if it's full. If it's thirsty, it'll do something different than if it's drunk. I mean, you can.
Yeah, we don't know what causes. We're pretty sure that one of the causes is anchoring, which is another thing that Kahneman talks about. You just see a random different estimate before you just gave this estimate, and it slightly modifies the next thing you estimate. That's just a random irrelevant number in a completely different area, actually affects your judgment. But also we know that risk aversion changes daily for reasons you're not consciously aware of. Control experiments have been done in this, where people are playing games of chance on a computer, and in a test group, they're actually exposed to, in the background images of the computer game, they're exposed to smiling faces, smiling families, photos of smiling families. Right. And the control group is not. They just see white screen background like this, right? Well, the people who are exposed to smiling faces are consistently more risk tolerant. They're willing to take higher risk bets for higher returns potentially than the ones that aren't exposed to that. And similar experiments have been done where people are asked to recall some event where they're really angry or recall some event where they're really afraid. I think, sometimes big decisions are made the way they are because.
Stay tuned for part 2 of this episode of The Valley Current.